So today we're going to look at the binomial theorem using Pascal's triangle. Now what the binomial theorem is, let's say that I have a binomial x minus 3 raised to the 5th power. And I want to be able to expand this out into a polynomial. We could multiply this out, but it would take a lot of work and a lot of time. And what the binomial theorem does is kind of gives us a shortcut to getting the expansion of something like this, of a binomial being raised to a power. So first of all, let's start off with what's called Pascal's triangle. Pascal's triangle looks like this. It starts out with 1 at the top, and then 1 and 1, and then the next row is 1, 2, 1, and then 1, 3, 3, 1, 1, 4, 6, 4, 1. And so let me stop right here and identify the pattern that's going on here. Each number in the triangle should be the sum of the two numbers that are above it. So like this 4 right here is the sum of 3 and 1. The 6 is the sum of 3 plus 3. This 2, 1 plus 1. Any of the 1s out here on the edge are the sum of 1 and nothing. And so that's why we keep that 1 along the edge. So this is Pascal's triangle. And these numbers actually become coefficients on an expansion of a binomial. So let's start with one that maybe we're a little bit familiar with. Let's say that I have the a plus b squared. A plus b squared. Now if you're familiar with this pattern of expansion, it's equal to a squared plus 2ab plus b squared. And if we consider our coefficients here, my first coefficient is a 1, then I have this 2 here, and then a 1 at the end. Notice this matches those numbers in the second row of Pascal's triangle. So let's try this idea with the next row. Let's say that I have a plus b cubed. Well, if I use this row of Pascal's triangle, I'm going to have 4 terms in this polynomial, and these are going to be my coefficients. And so my coefficients are going to be 1, and then I'm going to leave some space here because we need to go back and talk about the variables and the exponents. My first coefficient is going to be 1, and then 3, and then 3, and then the last one's going to be a 1. Now, each term is going to have an a and a b, and my exponents on the a and the b should always add up to 3, to the degree that I'm raising my binomial to. So for example, my first one, the a is going to start out with a degree of 3, and the b is going to have a degree of 0. And so really, when we write this term, it's really just going to be a cubed. We don't have to write the b to the 0. Then on our next term, the a degree is going to go down by 1. It'll be squared. And the b degree is going to go up by 1. A squared, b to the 1. 2 plus 1 is still equal to 3. And so those are going to be our exponents for the second term. Plus 3a squared b. All right, the next term, my a exponent is still going to decrease. First it was 3, then 2. Now it's a to the 1. My b exponents are increasing. We started out at 0, and then 1, and now this one is 2. And so this term is plus 3ab squared. And finally, the last term, the exponent on a becomes a 0, and the exponent on b, went to 4. The exponent on b would just be 3. And so my final term, since it's a to the 0, that's just 1. I don't have to write it. This is just going to be plus b cubed. All right, so let's look at another example, and this time we're going to try a power of 4, but instead of just using a and b here, let's introduce a number. Let's say we have x plus 2 raised to the 4th power. All right, so my coefficients are going to come from this row of Pascal's triangle, the 1, 4, 6, 4, 1. And so I'm going to have 5 terms here. My first term is going to have a coefficient of 1. Then we're going to have x to the 4th times 2 to the 0. Plus, the next term is going to have a coefficient of 4. And then I'm going to have x. The degree on x is going to go down to 3. And the degree on 2 is going to go up to 1. Next term has a coefficient of 6. And then I have x. The degree is going to go down to 2 times 2. And the degree on 2 goes up to 2. That's a lot of 2's. Plus, the next term is a 4. X, the degree on x goes down to 1. The degree on 2 goes up to 3. And then finally our last term, plus 1, x to the 0, 2 to the 4th. All right, so let's go back and simplify this and see what we end up with. On my first term, I have x to the 4th and 2 to the 0, which would just be 1, so that simplifies to x to the 4th. Plus, in my next term, I have 2 to the 1, and so I'm going to multiply the 2 and the 4, which will give me 8 x cubed. Plus, in the next term, 2 squared is 4. And we got to multiply that times the 6, so I get 24 x squared plus, see, in this term, 2 cubed would be 8, and I need to multiply that times the 4, so plus 32 x. And then in my final term, I have 2 to the 4th, which is 16, times 1 would still just be 16, and it's x to the 0, which is just 1, so I don't need to write it down. And so there is my expanded polynomial. X plus 2 to the 4th is equal to x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. Let's do one final example. And this time, x minus 3 to the 5th. So actually, I'm going to go back to my last version of Pascal's triangle. So if I go to the 5th power, I need to add one more row here to the triangle. So I'm going to have 1 out here on the outside. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. And then a 1 at the end. So my coefficients are 1, 5, 10, 10, 5, 1. Let's go back over here. I'm just going to write those out here. 1, 5, 10, 10, 5, 1. That's the row from Pascal's triangle that gives me the coefficients on my polynomial. So let's expand it. First term is going to have a 1 times x to the 5th times negative 3. Notice that my last term there is, the last term in my binomial is negative 3 to the 0. Plus, my next coefficient is 5. And then I'm going to have x to the 4th, negative 3 to the 1. Plus, my next coefficient is 10. and then I'm going to have x to the third, reducing the exponent by 1, negative 3 squared. Again, my coefficient is 10, x squared, negative 3 cubed. Next coefficient is 5. X goes down to a power of 1. Negative 3 goes up to 4. And finally, 1x to the 0, negative 3 to the 5th. All right, let's go back and see if we can simplify this and get our polynomial. This would be equal to, first term, negative 3 to the 0 is just 1, and so we have x to the 5th. Next term, I've got negative 3 that I need to multiply times the 5. So we're going to have minus 15 x to the 4th. Next term, negative 3 squared is 9 times the 10. So plus 90 x, whoops, I wrote 10, plus 90 x cubed. Let's see, next up, negative 3 cubed is negative 27 times the 10 would be negative 270 x squared. Next up, negative 3 to the 4th is 81, and we need to multiply that times 5. So we're going to get plus 405 times x. And finally, the last one, negative 3 to the 5th, would be negative 243, and we're just multiplying that times 1. So minus 243. And so there we have it, the expanded version, x minus 3 to the 5th.